Anyway, I'm yakking about local gauge invariance and its correspondence with this updating orders
Cool.
thing, but I'm not sure it's very relevant. Okay, so supposedly I've got a new version here in which things will not fail.
It looks like Jonathan is here
By the
too.
way,
Yes, Max?
yeah, I have a question about the rule plot. So, do you think vertex sizes should be consistent across different rules?
Within a single rule plot.
Well,
saying different
within
chances.
or maybe even across different rule plots.
Across different rule plots, not so much. Within a single rule plot, maybe. I don't think it's absolutely critical. I don't think it's absolutely critical.
Okay.
Jonathan, I was yakking about connections on fiber bundles.
Okay.
Because I'm trying to understand how to think about the notion of updating order and the notion of when things update and whether you can think about that, the relationship between different updating orders in different places as being like a connection. I mean, in the general relativistic case, right? It's well, do you have any response to that?
Well, gauges are connections. I mean, that's
I know.
right.
I know.
So
I know.
Do we gain anything by saying that? I think it's more concrete.
Yes, if we have local gauge invariance. If we had local gauge invariance, we gain a lot. Right?
By thinking about it in terms of connections? How?
Well, no, I'm saying, look, the question is, the statement that there's local gauge invariance is a bigger statement than just, oh, it's a gauge.
Right, it's the yes.
And so the question is there a property of our systems? I mean, causal invariance is not as fine a statement, I think, as local gauge invariance.
No, it's the distinction between confluence and strong confluence. Strong confluence is the statement of reconvergence of critical pairs after a single step, which is the local gauge invariance case. General covariance is confluence.
Okay, this is a very interesting claim that you're making very confidently.
I don't know. I think that's true, unless I'm missing something.
Okay, but if there's local gauge invariance, that implies a whole bunch of tentacles of local gauge invariance gives you gauge theories.
Right.
And those are kind of worth having. So if it's true that there's a criterion for local gauge invariance, that's highly interesting.
Well, I mean, the condition of strong confluence is precisely saying that, in effect, the system looks confluent even with spatial locality, even if one enforces a strong condition of spatial locality.
In what sense? What do you, I mean, why do you say spatial locality?
Well, I mean, if we're assuming that, except in cases where you have entanglements and things, there is generally a correlation between spatial locality and network locality.
Yes.
Strong confluence.
Okay, so your claim is strong confluence is associated with local gauge invariance. And that you say confluence at all is associated with some kind of global.
I think that's general covariance. Yeah. So I'm much more confident about the general covariance case because I think that
Yeah, I agree with you. That one I've thought was the case for a long time.
Yeah, if that's false, then the whole general relativity derivation doesn't really work. But
right.
Yeah, the strong confluence is local gauge invariance. That's just because. So as a reminder, right? Strong confluence is where you have common rewrite. You have a common expression A. You have any arbitrary rewrite sequence leading to B.
Sorry,
and any.
One second. Wait 1 second. I just trying to record this. gauge. You know, I have not written the word gauge in a long time. As of tomorrow, it'll be 40 years since I got my PhD. Isn't that?
That explains what
The
you were
tweet.
doing earlier.
Yeah, the tweet.
Right.
I was asking the question, do PhDs expire? As most certifications do. Okay, in any case. Okay, so reminder about strong confluence.
Right. So strong confluence is where you have, you're saying there exists any arbitrary rewrite sequence that takes A and transforms it to B, and any arbitrary rewrite sequence that takes A and transforms it to C. You know, the regular claim of confluence is that there then exist rewrite sequences that cause B and C to converge. Strong confluence is the stronger claim that there is a single rewrite you can apply to B and a single rewrite you can apply to C such that they reconverge. So it's the local version of confluence.
I understand. So that means that, well, it means that there's a bounded time, in a sense, bounded number of steps, confluence after a bounded number of steps.
Right. It puts a hard limit on the space-time interval over which one can have gauge invariance. Or over which one must.
Okay, so what's the derivation then? Given that, you know, one's forced to have gauge fields.
Right.
Right? And let's understand how that happens in our case. Because the usual derivation, I mean, the intuitive version of this is, you've got an electron, it has a hedgehog of electric field lines coming out of it, right? You move the electron, the hedgehog of field lines has to move.
Right.
But at infinity, you know, far away, how does it know that the electrons have moved? Well, answer, there has to be this kind of you know, wave-like thing that propagates out, and that's the photon, roughly.
Right.
So in our case, it's like something happened, and there's some sense in which, you know, how would the system know it, type thing.
Right. We should be able to see some ripple in the causal network.
Yes. If you do something, there should be a ripple. So in this case, making a perturbation, like a Green's function-y type thing, a gauge ripple in the causal network. Anyway, just a thing to be looked at in the future. Anyway,
Yeah,
I just thought, yeah, go ahead.
I have to say, I'm not sure we gain. I think it's okay. I at least find it easier to think in terms of concrete gauge choices, like like ADM type things, than to try and define like the discrete analog of a fiber for each point on the hypersurface.
I understand. I mean, that's what we're looking at then, is the space of all possible rewriting orders, right?
Yes, right.
You know, the space of gauges is like the space of all possible rewriting orders. And that means that that corresponds to the connection field, effectively. The rewriting orders are defined by a connection field of some kind.
Well, yes. Yeah.
By a local, potentially local, connection field. Because that's what determines, I mean, well, that's what determines, at least from, I mean, look, it's the potential, right? It's the local potential, which is whose connections between different places. Yeah.
I still think there's a more concrete way to think about it, which is that if the causal network limits to a four manifold, limits to a remaining four manifold, then the updating order is, because the causal network corresponds of this. I mean, it is a network of events. The updating order is basically saying if you at a point in the causal network, you know, what is the next point you should go to in the causal network? And so if it limits to a 4-manifold, all that's saying is you're associating with each point in space a relativistic 4 vector, which is exactly what you do in, you know, with concrete gauge choices in ADM.
Okay, I understand. So there's a forward light cone basically of every, you know, in the normal case. So this is saying you can associate some forward light cone with every point. Is that correct?
Right, right.
By the way, okay, just entertainment moment. What do we think the analog of event horizons and so on is in our world?
I think we discussed this the other day. I mean, my view is it's just a reachability question. It's, you know, if you...
Yeah, okay, fair enough. I agree with that.
Right.
Yeah, right.
If you're in the causal network, you reverse the directions of all the directed edges. It's like, what points in the causal network can you reach? And you get a very
Right.
sort of...
Event horizon, reachability.
Right. It's quite nice, actually. It's a very concrete version of a Penrose diagram.
Yes. And we should figure out whether we actually have some of those. I mean, we'll see. Yeah, very cool. All right, let's look at some causal networks. Let's look at some other things here. Gosh, if we can connect the infinity groupoid and Penrose diagrams, we're really doing well in the world of just insane connectivity. I think, I don't know what oh, for God's frigging sake. Packlet set replace not found.
That means you already uninstalled it. That's fine.
And look at that, it just works. Okay, we didn't by any chance get the thing that that gets only the right section of the multiway system file, did we?
So I did get something from Rick. The only problem that I see right now is it opens the notebook, and it automatically does run the definition notebook, but it opens the notebook. If that's okay, I can send
it's okay, although there's a front end option to prevent that, to not have to have that.
Okay, I will send it to you right now. And
what is this? Max, the one argument form of Wolfram model is symbolic, isn't it?
What do you mean?
Why is this giving an error here?
Well, because argument for the Wolfram model should be rules.
No, but it shouldn't necessarily be rules, because we have to use it as a left-hand side assignment. See what I'm saying? In this function, we're using it.
I see. Okay.
So you just leave it symbolic. Don't give a message. Just leave it symbolic.
Okay.
Okay. All right. Are we ready to roll here with we're going to look at Jonathan's multiway. Let's see. I assume the multiway system got updated in. Did it get updated in the function repository sources?
No, not yet. But I can hang on. Let me put a version. Let me put a draft version up.
Okay. Why don't you rename? Hold on. Let me rename. Okay. But what do you want to put? Function repository sources. Why don't you say multiway system dash okay. 01 or something?
Just to be on the safe and non-confusing side, I'm putting it in my own folder. I've added my draft. No, okay.
Let's not do that. Let's put it in the main one.
Okay.
Just say multiway system dash 01.
Okay. I tend to get confused with these 01 naming.
I know. Well, we all get confused with different things. And Max is the only one who doesn't get confused with continuous integration and all possible software engineering tools.
I think this is the right version. I mean, this code is still obviously not tested very well, but it seems to work.
Okay. And how far did you get? I mean, have you got?
So I have traced states graphs. I have evolution causal graphs, and I think I have basically everything else that makes sense, apart from the evolution plot, which requires some graphical stuff that I haven't mustered up the courage to experiment with yet.
Okay, but I think we also don't want quite the same thing for Wolfram model there. I mean, there we're going to have little tiny. Yeah, okay, but remember the spacing that we've got for evolution plot is completely stupid for Wolfram models at every node type thing, right?
Right. So I'm a little bit worried about porting that.
Okay. All right. So I should run the definition.
Yeah. Sorry, there's a lot to evaluate.
Oops. What's this?
Yeah. That's part of. I haven't split it up into examples. The examples are in the definition. Sorry.
Okay. Okay. So the old code, this has not yet merged these different pieces of code, right?
No, this is basically just my rewrite of it.
Okay, but how far did you get, and where is the? Okay, well let's take a look at what you have here.
So I mean, all states list unmerge, all states list, states counts lists, predecessor rules list, states graph. Basically everything other than the graphical stuff should work.
Okay, so we should be able to merge these two things, where we take. Okay, well, look, you and I should. I mean, maybe Sushma, but it doesn't involve Max to do this. But here, okay, this is driving me crazy. Okay. Okay, so look, I just think these are just nuts. These edges. Okay, what I think we should do. So first of all, we need a different graphical form for the events, right?
Yep.
And what I was suggesting was that and we could probably put that in right now. That, I mean, in the case of this type of plot, we actually don't want the arrows here. We want an arrow at the event, so to speak.
Right.
Okay, then what I'm suggesting, so can we try doing that right now? I mean, and then what I'm suggesting is that these edges here, right, that these dotted edges, see, something like this is just bonkers, in my opinion, going that far, right? Because what is that? That's a thing which is essentially an edge that's routing through there, and through there to this event, right?
Right.
But why it flaps out to the side, I have no idea. Because really what that is just, I mean, it's like there's a bundle of wires coming down. I mean, I think this is what I did once in the NKS book when I did this. Let's look at what I did. I thought I had a more elaborate version of this. Anybody remember by any chance? Oh, so those are confluent ones. Okay, so in this case, I mean, we could just rerun this thing here, right? So the one thing that we don't have.
Oh, this is what you want to modify.
Okay.
That's the last line of the final function in the definition. If you replace that.
Which definition?
So the final function, there's a thing that says graph union flatten edge list, and if you replace that with what I just posted.
Okay. It's always very suspicious when you just pick up a piece of code from the triangle is going the wrong way. Okay, so how do we do that? I'm guessing it's down triangle. Well, I don't know what triangle. We'll go look that up. And then what we want for the edges is not to have, but we don't want that arrow there, right? We only want these arrows here. Okay, so we need to get that. But now here, notice that the rewrites.
Sorry, just to clarify, were you saying you want basically to have the whole thing as a hyperedge going through the triangle? Am I understanding correctly?
Yeah, that's what I'm saying. Yes.
Yeah. Okay. I can do that.
I think so. I mean, I think that. But on the other hand, what I really, really want is these things. You know, we got to figure out some way of representing the causal relationships, tracking along these sort of evolution relationships. See what I'm saying?
Yep.
And I'm thinking we might be able to do that by having sort of ribbons. The evolution line be a ribbon with multiple things in it. I'm not sure if that's right. That may not be right because they have to cross over and things. But by the way, I'm noticing that in here, we have one thing that we have not done, which is that the rewrites here are actually indicated with extent like this, which I don't think we've done. We've only got the closest we've done here oh, we have got that. Oh, that other one is a single rewrite. It's a single path in the multiway system. Yeah, that's why the things don't overlap. Here they overlap. No matter. Okay. By the way, you don't have to say substitution system arrow, right? You have that code or not?
No, but that's an easy change.
Okay, but we're going to have to merge the code that's here, right, with the code that you have.
Yeah, sure. I can do that. When I remove the arrow that's going into the updating event, it kind of destroys the structure of layered graph plot.
Well, I mean, you just have to not render the arrow. It's an edge rendering function of some kind.
Okay, I was sorry. Okay, I was just making one edge undirected, but maybe that was too hacky.
No, that's much too hacky.
Okay.
That won't work because we'll want to work out graph theoretic properties and things. Okay, meanwhile, let's look at some of Max's work. So, you are saying, Max, that I can say hypergraph plot. How do I get a random hypergraph? Did I already have a function for random hypergraph? Yes, I do. Oh, it's using the hypergraph wrapper. Do you deal with the hypergraph wrapper?
No, not yet.
Could you optionally deal with a hypergraph wrapper? What the hell is that? So now if I say vertex labels, okay, 1, okay, okay, looks pretty reasonable. Now the 7, 7, why is that filled in?
Well, it
Oh,
fills
7.
in all edges.
Oh, actually, look, 757. That's why it's
Even
filled
if
in.
there are two edges. No. 757 is why the space between the two multi edges is filled in. But 77 has two edges filled in.
Okay.
Because for consistency, I don't actually treat two edges in a different way. No.
Okay. Where's the find canonical Wolfram model? Did I have that in my which file do I have that in? Do you know, Sushma?
You do have it in your function repository.
Oh, maybe I already read it in. Did I already read it in?
Yeah, that's
Yes. Oh, I got all of those. Okay. So random Wolfram model rule. What does it mean? Okay. Okay, so now I'm getting the signature, which is something like 4342. And then the number of symbols, let's say 4. Oh, for God's sake, why didn't that work? Oh, because it's got to be a signature of the form. Right. It's got to be like 3322 goes to that. Okay, there we go. So now I say rule plot of Wolfram model oh, they're still red. So now can I say vertex labels arrow here?
Yes, it should work. It's not as stable as hypergraph plot yet, but it should work.
And I assume it has an image size option. I noticed you didn't do the shaft of the arrow yet.
Yeah, I don't think image size option will work right now.
Okay.
Yeah, I didn't update the package since the morning. I'm actually working on fixing the issue where sometimes the self loops are different sizes on both sides of the rule.
Okay. I don't think that's that devastating, actually. I mean, unless it's the
In
same
this case,
self.
it's not. But if you try to plot, say 1 1 goes to 1 2, you will see the problem.
I see. Okay.
We also need to figure out how to not make options red.
Don't you just put it in the options list for, oh, I see, with an up value. God, I don't know how to do that. That's a tricky thing, and you might have to ask somebody. Okay, well, this is super hard to read, but then it's a super hard to read rule, too.
Well, besides brain electrical embedding, I'm not really sure what we can do here.
Say that again, what?
Besides brain electrical embedding, I'm not sure what we can do here.
Well,
we
okay.
can also try to do it in 3D.
In which? 3D?
We can also try to do it in 3D.
Yeah, did you manage to get hypergraph plot 3D?
No, but it's not hard to do.
But you should do it. Highly worthwhile. Okay, well, that's hard to understand, but so it goes. I mean, if we get some really, really good rules, we'll have them custom laid out. Luxury rules. Okay. So what you're saying now, if I go to well, let's just say I do this one here, and I just do, so in this case, I can say Wolfram model of that, comma, and then my initial state could be just something like this, right?
Well, it wouldn't do anything because input of the rule takes 5 edges.
Oh yeah, good point. Okay, so let's say, let me just say, oh, for God's sake, what did that do? Oh, that's a singleton. I meant 1. Do you think that the signatures are the right way around, or should they be the other way around?
Let's see, I think they're right. Count and then type.
All right. Okay, that's very weird because those are disjoint objects. Do we have something that automatically starts, if we just say automatic as the second argument, could we get it to do the minimal, the self loop of the right size?
Well, it doesn't do it, but it's possible. Let's see.
Can we interrupt this thing, given that it's obviously going crazy?
It should work. So given that it is joined, this is purely Wolfram language code.
I see. How do we test if a hypergraph is disjoint? I mean, it's obviously easy, but is there a graph disjoint queue or something?
Well,
I really
not
think
exposed.
Okay, that did not interrupt.
Well, but it. Okay, can you try to run the same thing with method goes to low level?
Okay, hold on.
Because
right?
because if
Is that the right
not,
thing? Is that the right thing?
I think so.
Okay, so apart from the fact that this is, I don't understand why this is not. Oh, that's right. It looks right. It's kind of funky, but it looks right. That's kind of weird, and that will only work with the brains world, so to speak. Okay, where's the, so did you put the Wolfram model documentation? So are we going to basically put Wolfram model into the function repository, but with something which loads the packlet, right? Max?
Well, I think we can do that. But
Okay.
what do you do with other functions? Should it, I mean, so, okay, one problem is that these functions depend on each other. So for instance, rule plot uses some package scope functions from hypergraph plot.
But I know, but it's got hypergraph plot. Okay, I see what you're saying. So, well, we don't have a great solution for this right now in the function repository. I mean, other than that, you can use it, you can load a packlet, and you can just try and make sure that that packlet is loaded. I think the best thing to do is that each function should try to load the packlet and should check that it's loaded. So the first to arrive will load the packlet. And then those things will be there. Make sense?
Yeah, that will work.
Okay, so Sushma, one of the things we really need to achieve in the very near future is getting together everything that's going to be in our first load of function repository functions for this project.
Yep. Okay.
Okay?
Mm-hmm.
And I think, and again, that guide page, how are we going to build that guide page? Do you understand my question?
I know, I understand your question. That was one of the questions I wanted to ask the DPS team tomorrow in my meeting with them.
Good. Okay, fine.
It would either be them or I next I thought I'd go to Brian V.
Okay, fine. But fundamentally, what we want, that can just be either a pure HTML page or a cloud notebook page.
Yeah.
Right.
Yep.
But one thing, by the way, when you, just to forestall one issue, we don't want the really heavyweight rendering of a function repository function there. We want a little light, you know, thingy on it.
Yeah.
Okay. All right. So what did we learn from, well, Jonathan might be, Jonathan, you should interrupt us as soon as you have something to say about this. Oh, and by the way, what was the Rick's utility for doing, for loading?
Yeah, I sent it to you in my
Okay.
email.
Okay. Did it, oh, that's it.
I mean, I tried it. It works. It just opens the notebook and runs the definition because it does selection.
Why does it have an open notebook object there? You've got to open the notebook first.
Yeah.
Okay, so what we want is something like,
Does it? I see what you're seeing.
I want something where I just say, you know.
Do you give the file path?
Yes. I mean, in a perfect world, one of these deployment things, something like this should be able to give you the piece of code that will do that.
So what we could do is, really, we should do, so deploy, so if you go to the deploy thing, so you do deploy, I mean, I don't think we really care. We could do publicly in cloud.
Yeah.
And then we have in the your utilities function, resource function of that link, and it will automatically load the definition.
I understand. I would prefer that when we redeploy this, right?
Yeah, you'll have to redeploy that.
Yeah, you have to redo this, which is
Yeah.
really icky.
Yeah.
Icky. Right, that's the problem. Really, what the problem here is this. What we really want to be able to do Well, I don't know. For my cloud account, does it deploy? Let's take a look. Does it deploy to a random name, or does it deploy? Let's see what it deploys to. Is it going to deploy anyway?
Yep.
Okay, so let's see what this does. This is my weird username, but I don't think I need to use that, right?
I think you need to use that.
I think I can use s.wolfram instead.
I see. That's probably fine too.
Okay, so you're saying that if I do well, that seems perfectly fine. And if I redeploy it, it's going to go to the same place.
Yes. So, I mean, if you do resource function, you could just use it as a resource function.
Yeah, I agree. No, I can't. No, I can't.
Why does it show find canonical Wolfram model?
Because that's a function called inside here that
I
wasn't
see,
defined.
I see.
So this is this whole business about deploying multiple resource functions, right?
Actually, I still don't get why find canonical Wolfram model is showing up, because your definition is, oh, I see. Never mind. I got it. Yep. Yeah.
Where is it defined?
It's in another function repository notebook.
But how is it supposed to find it?
I mean, when we actually submit it, we'll probably submit find canonical Wolfram model too, and then we write it as resource function of find canonical Wolfram model in that definition notebook.
No, but as Max is saying, the definitions thing should have picked up that definition. Why didn't it pick up that definition? You understand what I'm
Because
saying?
I don't think it is. I don't think it is evaluated in place.
No, but that's not the point. The point is that it should be finding all the subsidiary definitions when it packages this up. It's got to do that.
I mean, I don't think it does include definitions. I think it.
I don't understand where is it supposed to find it if it's not in this definition.
It's in the function repository.
Well, privately.
I see what you're saying.
I think we should refer it specifically by resource function to make it work.
Yeah,
right. Right, but that's no good because eventually we're going to want it in the public repository.
Yeah.
Okay, so listen. The next few days, we need to get everything that's here consistently in the public repository, okay? Even if some of these things are slightly lame and not really finished, although we've got to get some basic documentation.
That's fine, yeah.
Okay. Fair enough. Jonathan, did you manage to do an iteration of this thing?
Sorry, what was I meant to be doing?
Fixing this. We were waiting for you to fix this thing.
I mean, I have an improved graphical layout of it.
Yes, that's what we were hoping for.
Oh, okay. Sorry, I was just doing general code merge.
Well, that's good too. Okay,
yeah,
do I need to not save this file?
I don't know. Well, hang on. Let me see what happens when I just save on this end. Sorry, let me finish. I was writing something.
Yep. I'm going to not save here.
That's probably for the best. Okay, I'm not sure if this is going to screw something up, so I'm just going to comment that out. Okay, now I have to do this renaming trick.
So I'm sorry, just clarifying what Max is doing. So one thing that we'd sort of forgotten is hypergraph plot 3D, which I think is quite important.
Well, I
This
didn't
is all
forget about it. I just didn't get to it yet.
fair enough. Okay, Jonathan, ready to reload this?
Well, hang on. So, all I've done really is I've changed the event icons to be diamonds, and I made them a different color, but it's still the same unreadable thing it was before.
Okay, well, let's look at that.
Okay.
Okay, so did I load in the right file here? I just reloaded this file. Is that the right thing to do?
Reload it again.
No, you have not updated the thing in Dropbox. Multiway System 01 has not been updated.
It's showing updated on my end. Hang on.
Just updated.
Okay.
Okay, well, look, it needs to be, can you not make it a triangle, or does that require more code?
I can do, but I'm sure there is a way. I just need to look up how to do that.
Okay. All right. Okay. Okay. Clearly, this is not going to work with all these dotted lines here. It's just crazy, right? So the only question is, what is the right way to do this? Right? So we've got two choices. One is it not the case that every solid line at the position, okay, how many things can a solid line go to? How many new solid lines can, okay, if we keep the causal structure in the solid lines, then we can, solid lines can split, can't they? Do you understand my question?
Not really.
Okay, let's go back to what we were talking about before, right? So a solid line, if we look at, let's look at the multiway system. Where's a good example? Okay, so here, each one of those is a solid line, right? So it's a double edge in this case, right?
Mm-hmm.
Each one of those then goes out in another solid line, correct? Or possibly more than one solid line. Do you see what I'm saying?
Right. I mean, what's actually happening with respect to the causal structure is we have essentially a hyper edge, a thing that links a collection of hyper edges.
Why are they hyperedges? They're regular edges, aren't they? And this is a multiway graph.
Right.
The update edges are regular edges.
Right. What you have is each edge is connected, but not to a single other edge. It's connected to an arbitrary number of other edges.
Exactly.
So it's the edge equivalent of a hyperedge for vertices. That was what I meant by hyperedge.
Well, in other words, it's a hypervertex that has, well, it's not really a hypervertex, just a vertex that has, okay, each hyperedge is connected to multiple other, each edge is connected to multiple other edges.
Each edge is a vertex in a hypergraph, is my point.
Yeah, that you could think of it that way. But each edge is simply connected to some number of other edges, right?
Mm-hmm. Right.
Okay. Now let's look at my little picture. Okay. So that was my picture, right? Where each edge coming in, right, goes through this and connects to some number of other edges.
Right.
Okay. Now we can't see that in, you know, wherever it is. We can't really see that here, right? So what we really should see is like this edge comes in, right? And it connects to these two edges here. But I mean, in general, two edges could come in, like down here, for example, multiple edges are coming in, right? Mm-hmm. And some of those edges are connecting. Each one of those edges, each incoming edge can connect to some number of outgoing edges, true?
Yes.
But it can't be the case that multiple incoming edges connect to a single outgoing edge, correct? Is that true or not?
That sounds plausible, yes.
So by the way, I assume that the code, let's see, hold on, let me just pick something out here.
I'm still not sure that this new visualization is going to give sufficient disambiguation between evolution steps and causal relations.
Nor am I. But let's just push it forward a little bit more, okay? So okay, so this is visualization. Okay, so what we're saying is each incoming evolution edge is causally connected to some number of outgoing evolution edges. Is that correct?
Yeah. I mean, evolution edge is a strange way of saying event.
Well, I know, but I want to call it an evolution edge for now, right? Okay. Because that's how we're thinking about this. And then so I don't understand why we don't just break each of these nodes I don't understand why every incoming edge here, okay, think of this node as a big puffy area, okay? And every incoming edge coming into that node comes into a different part of the puffy area. See what I'm saying?
Okay.
And then every node just goes to some number of outgoing edges. Sorry, every edge, it's like this, for example, right? comes in, breaks like that. But there could be multiple things coming in here. We just have to distinguish which one is coming in where.
Right.
Right? And that will give us the right result, won't it?
How does having things come into the state vertex at different points tell us anything about the causal connections?
It doesn't. What tells us about the causal connections is, look, the causal connection is defined by this event is connected to these two other events, right?
Right.
That's the causal relationship there.
Mm-hmm.
Okay, so what I'm saying is there can be multiple evolution edges which are coming into a single state.
Yes.
Okay, each evolution edge goes out to certain other evolution edges.
Mm-hmm.
Okay, all we have to know to understand the causal connections is within this state, there are things coming in. There are multiple evolution edges coming in. Each evolution edge can have some number of edges coming out.
Right.
So all we have to do is not tangle that up too much, and then we've maintained the connections.
Right.
We've got the causal information.
Right. I understand.
So what I'm suggesting is that what we do, and I think we have all the information to do this, is we just make something. Now, I don't know exactly how to do this, where you get what I'm saying? So long as
No, I understand. But all you're doing there, as far as I understand it, is moving the information that's conveyed by the dotted lines inside the vertices.
Yes, that's what I'm doing.
Okay.
Because I think it's going to be a lot clearer.
Really?
Yes.
To me that
yes.
seems even
Look
more
at
obscure.
No. Look at the complicated cases of these dotted lines. You just can't follow what's going on.
Right. Because it's, you're representing the causal structure of an entire, of every possible evolution of a universe. It's going to be a complicated thing.
I know that, but the whole point is if you do it this other way, you're making it clear, locally, you can look at each thing and see what it's doing, right? Globally, yes, it's a big mess and you don't want to look at this and you'll want to look at the causal network instead, throwing away the evolution. The point of this is showing the transition between the evolution network and the causal network.
Okay.
Because the whole thing is going to be totally incomprehensible, I think.
Right. But this way, we're moving the incomprehensibility into the vertices.
Yeah, but I think it's going to be better. I mean, we can provide both options, but I'm pretty sure it's going to be better because this thing, when it gets complicated, I mean, if you take this, okay, I don't know whether that's a particularly interesting. I don't know what this did. Did that do something trivial? Oh yeah, it's just sorting or something. Let's take a non-trivial example. Those ones are all trivial examples. Let's take one of these down here. I mean, it's just going to be a total mess. I don't know. I can't see anything in that. I just can't follow these things, right? I can't follow the causal relationships because the thing is primarily, I don't even know how we made those causal. I mean, it's kind of cool, but I don't think it's going to be useful. Great. By the way, another thing we absolutely have to do is to make these plots so that the events at successive steps are arranged down the page.
Yeah, I agree. That's worth doing.
And I don't know quite whether you can They're horizontal positions. I mean, they could be on a grid horizontally, I would think. Well, that's not great. Is there a way of doing that, Max? Do you know how to do that with vertex coordinates and so on? To constrain the y values, but not constrain other stuff? No? Max, hello, are you there? No. He's still on this.
Hello?
Yes.
Yeah, something's wrong with my microphone. I don't think right now it's possible to do it with vertex coordinates.
Okay. What about with a layered graph plot? Can we not define what layer it's at or something? I mean, if we take this thing is a graph, right? Oh, we can certainly say what the root node is. Right?
Yes.
Okay. Okay. So what we need eventually here is probably a layer. Can we not say, is there a way of saying layered graph where we're what we could do is make a layered graph plot and then take the vertices, take the coordinates and feed them back into the graph. Am I making sense? In fact, you just say graph embedding arrow that thing with a layered graph plot, right? Do you understand what I'm saying? Do you understand what I'm saying?
Right. Yes.
Vertex coordinates arrow graph embedding of whatever.
Well,
Okay.
pretty much, yeah.
I mean, sadly, I just don't find the dotted lines in the slightest bit useful here. Jonathan, would you like to comment on them?
I don't know. I mean, if you want to have multi-way causal networks, I think it's going. My conjecture is everything is ultimately going to be as complicated as this. I don't think this is a visualization problem. I think this is a conceptual.
I think it's a look. I think the whole point is you can locally trace it for a small number of steps by following these evolution paths, and that's what I think is useful.
Okay.
Well, I think if all vertices are labeled and you want to understand some particular part of it, these dotted edges are not completely useless, but they don't really tell you what the overall structure of the thing is.
Right, and these things aren't labeled, obviously, here, right?
Yeah.
I mean, in the evolution
Without
plot.
labels, I don't think it's very useful.
Okay, in this evolution plot, is there a way of combining the evolution plot with some kind of causal thing? You see what I'm asking? So in other words, given this, we know that one of these edges is associated with some other outgoing edge, right? Does that make sense? An incoming edge here is associated with a particular one or more outgoing edges, right?
Mm-hmm.
Okay, so what I'm suggesting is that in a picture like this, that we find some way to indicate that. Which incoming edge is associated with which outgoing edges?
Actually, is it actually that simple? It can be associated with outgoing edge, later.
Yeah, exactly. This is my issue. It only your thing only represents causal relationships that are instantaneous.
Well, but look. But it's transitive. I mean, you have to do the sort of transitive closure of this anyway, right? So in other words, if A is causally related to B.
I don't think that's true.
I don't think so, because the event as the next step might not be causally related to the previous one, but
you could have replacement rule A, then a whole bunch of.
You might have to change other vertices in order to use the just updated ones again.
You could apply rule A, then a sequence of rule Bs, and then rule C, where the input rule C only matches.
You're right. Okay, you're right. So in fact, it is the case that my going through a vertex scheme will simply not work. Is that true?
Right. Well, I think so, because then what you're going to have is, evolution edges connecting vertices in a way that is not actually permitted by the rules of the replacement system.
Okay, fine. All right. Okay. I concede. Okay, but what are we going to do to make something better than this? Because this is really incomprehensible. So in this plot here, there's a causal relationship graph that we could get out of this presumably as well.
Okay, I have one idea. Maybe the solution is to make it interactive.
That doesn't do us any good in presenting these things. But what's your idea?
Why not?
Well,
suppose we don't draw the entire causal network right away, and we need to pick a path in the states graph, and then we show the causal network once the path is picked.
I'm totally confused by that comment. I mean, the whole idea here is to show the complete set of causal relations between all events. Right? Given a particular path, we've got a completely different story.
Yeah. Okay, I have a potentially kind of obscure suggestion.
Yeah.
What if we did something along the lines of, we take each branch of the multiway system and we assign it a color. And then, if you have causal relations that exist only within one branch of the multiway system, they also have that color. But where you have causal relations that kind of wrap between different branches of the multiway system, there's some kind of gradient interpolation, so that you can see at a glance how different branches of the multiway system are being causally related, without having to trace the individual relations.
I think it won't work because of just human color perception. Every time I've tried to do something like that where there are like 30 colors, it doesn't work.
Okay.
All right, let's look at this picture again, okay? So this picture, should we look at, okay, so we think the layered graph plot is an accurate representation of what's going on, right?
Mm-hmm.
Let's look at this picture first. By the way, why do these things wiggle in this weird way? How are those being generated?
That's just the default layout.
Really?
Yep. I'm not doing any graph layout, anything.
Why are those guys wigglers when the I mean, why are these ones straight and these ones wigglers? That's probably a question for Charles Poo. Maybe we should ask him.
Right. I mean, in this case, it kind of works.
Yeah. Okay, if I try to label this graph, will it be in the slightest bit useful, or will it be just utterly obscure?
I think it will be useful.
Okay. Okay, so how do I do that? Can I just say vertex labels goes to whatever?
Let me see if that works. It does not work. Hang on. Yeah, I have options for the states graph, but I didn't do it. I didn't add options for the evolution causal graph yet.
Okay. Okay.
And even then, the options for the state graph are kind of bad for the Wolfram model case, because I'm not integrated with hypergraph plot, so it displays them as matrices or
yeah, I understand
other
that.
bizarre things.
Okay, but we can integrate with that. Okay, so is there any way to get labels other than these here?
I mean, we can
Don't we have an option to give labels which are different? Don't we have the option to give the full string label?
Presumably, yeah. Hang on. Okay, yeah. If you say vertex labels automatic in layered graph plot, it will do something, but it's not.
No. That's not what we want.
I don't think it's tremendously helpful.
No, what we want is exactly this, right? Make a label from the name of the node, use an explicit node name as the label, etc.
Right, but what about the events? I have that for states graph. If you call states graph on that thing and say
No, I'd be happy to just label the states here. Can we
okay.
do that? Okay, so if we say state graph labels, will it do that?
I don't think so. No, hang on.
Okay. Do callouts work on graphs?
At least in small cases, vertex labels automatic isn't too incomprehensible for strings.
That did nothing.
No, wait. You have to. I mean, put it in a layered graph plot.
That's not that bad. All right, let's look at this guy. So in terms of formatting, we could probably format this a bit better. Arguably, what we should do there is to have something which has a B and then sort of above and below BA, ABB, maybe. So what I'm saying?
We should probably add API function for formatting events. It should do different things for different systems.
Yes, I agree.
In this case, it could just print this. Well, it could print the string but split it where the rule is and then put the two cases vertically.
Yep, that's exactly what I was thinking. I mean, it's a little weird when there are null strings and so on, but not terrible. I think there's an option for putting
it could show some symbol if in case of null string to make it less.
Yeah. Oh, that's amusing. That's a null string there.
Right. And I'm noticing it doesn't have any causal connections, the null branch.
Which is why, because there's nothing to carry the information.
Yeah, right.
Yeah, we have a rule that says null to something. That, well, probably, I mean, that still wouldn't start there.
Okay. Well, look, we've got some, okay, so we got to add something. This is a detailed thing. We got to add something, which is the, I mean, are we going to add a state rendering function and an event rendering function? Probably.
Yeah, that sounds reasonable.
Well, actually, we got a state labeling function. Okay, let me make a different suggestion, okay? That what we do is we add a rendering function, and that the rendering function take as an argument event or state. See, because we're probably going to want rendering options for different things, right? We already know we want that. We already have that state graph labels.
Right.
That's essentially state labels. Well, there's I mean, each one of these could do something different. So, I mean, if we say state labels and event labels, then what they could do, yeah, I could simply pass into the rendering function, f of event, and then whatever the event is. Let's call it state rendering function, an event rendering function. Then we'll pass event together with the event labels, together with the setting for event labels. Does that make sense?
Right.
So that you can globally set state labels and event labels, but the state rendering function and the event rendering function are different for each. There are many choices for state rendering function that correspond to different things, like minimal. All right, so we could write the spec here, and we could write the things here. So okay, so that's one thing, is the state rendering function we got to do. Okay, I think you've convinced me that it's hopeless. Because I admit I hadn't really internalized this point about the multi-step dependence.
Yeah.
I mean, it's really complicated, basically.
And multi-branch, which is even worse.
Yeah. Okay. So it's useful to see and I have to say, in this picture, having the events like this, where you go to an event, then from an event, doesn't seem crazy to me.
Mm-hmm. And I'm guessing most of the time, for practical purposes, we're only generating this because we want a particular causal graph. We want to pick a branch.
Why would you say that? I mean, we're mostly generating this in order for people to understand how on earth, I mean, for us to debug how on earth something happens.
Okay, fair enough.
Right, that'll be the typical case.
I was viewing it more as, it's the most general way to get causal networks when we don't have confluent rules.
Yeah, we get all possible causal networks from here.
Right.
What does wait a minute, the multi-way causal graph is just the dotted line graph, right?
Well, I mean, this is the multi-way causal graph, isn't it?
No, it isn't, because it's got all this other crud in it.
Well, that's the multi-way system.
I know, but we don't want the multi-way system. All we want is the multi-way causal graph.
Oh, okay, right. You don't mean the union of the multi? Okay, yeah, sure. Yes, it's just the connections between the red nodes.
Right, and we have that as a thing from the multi-way system function, right?
Well, right now it's just there's a helper function that does that. It's called get causal edge list. But
okay, well let's make that. Okay, wait a minute. We've got several things here. Okay, so we've got a little bit of cleanup work to do here. That okay, the other thing we should try to do. Okay, hold on. Let's make a list. Okay, we've got state rendering function. We've got a causal multi-way causal graph. Actually, it's really a causal plot. Oh, wait a minute, don't we have a thing called causal graph here? states graph. Okay, so really what that wants to be is an events graph, right? Causal graph, which is otherwise known as an events graph. We do have it. We do have causal graph here.
Right, but that was specialized to the strings case. It relied upon a load of stuff about individual character updates and things.
Oh, I see. Okay, okay. So that's the generalization that we have to get, right? So what you've successfully done is you've got a generalized evolution causal graph here.
I think
correct?
so. Yep.
Okay, evolution causal plot is something else we'd mentioned, which basically has dotted lines adorning an evolution plot. Okay, so we've got a few things to do here, which I can probably usefully help with, to do with cleaning this up. Now, should we try to do one piece of integration, which is the Wolfram model hypergraph plot inside these, right? Because what we had previously, okay, there's a states graph version of this, right? Is that still your code? Can your code do the states graph now or not?
Yeah. As I say, it can do everything other than, the stuff that's specific to the strings case, I think.
Okay, beautiful. Okay, so let's do this for a Wolfram model.
Right.
Okay, so we would do that by having, this is going to put, okay, can we insert the Wolfram model, the hypergraph plot inside there is the real question, right? There's a rendering function. That's the state rendering function. Has to be a hypergraph plot. See what I'm saying?
Yep.
I think this is a thing for you and me to do. I don't think we'll. So Maxime needs to tell us what is the what's the in a hypergraph plot. Where did I have the hypergraph plots? In a hypergraph plot like this one, what is the range of coordinates?
What do you mean by that? Well, it depends on graph plot.
Okay, so then we're going to have an inset.
And it's very inconsistent, which is what I'm dealing with in the plot right now.
Okay, but is it correct that, wait a minute, in a graph plot, Maxime, do you know how the vertex, whatever it is, thing works? Vertex rendering function, is that what it's called?
Since it's vertex shape function.
Okay, function of x, y, the vertex name, and the bounding box okay, how do we do that? So does that mean we have an inset? I think it means we have an inset, right? Does this have examples? This is so freaking annoying. Oh, God. Okay, this is another thing for Charles. Okay, so that's putting in a rectangle. Okay, we got to see a version with it in an inset. Let's take this one here. And instead of a rectangle there, Well, here, if I say regular polygon, those are the center coordinates. Surely I can just give an inset. Does anybody understand how inset works well enough to be able to do that?
Not really.
Okay, object. Let's say inset position opos. Okay, so that says center there. And now size. Okay, so I think that's width height. Oh, for God's frigging sake. Okay, that's encouraging. All right, so now let's just put in there, I reckon, what's your favorite random hypergraph?
What's wrong with this one? Oh, I see. Now if I say vertex size, oh, come on. Why does vertex size not change then?
By the way, I just sent an example of the multi-way causal graph.
Okay. What the hell's going on here? Gosh. Oh, come on. Why does vertex size? Oh, because I got another vertex size thing in there. Silly me. Silly me. Okay. That's quite swank.
You should probably make background not transparent.
Yeah, it's pretty nice. Okay, so Jonathan, we're ready to put this in
Okay.
with insets.
Send me the code.
Okay.
Um,
Well, I think it'd be better to adapt it. Okay, what did you just send here? You just sent
a thing where we can see 4 sort of causally distinct patches of space-time from that evolution causal graph.
event horizons are galore.
It appears so.
Positively space-time foam. Or something. Although these are the multi-way causal graphs. So any given causal graph, well, in the case of causal invariance, can this happen?
No, I don't think so. Not in this way. Well, actually, hang on. I think this rule is causally invariant, so I take that back. No, it.
Okay, well, so the basic point is that into the states graph for this thing, we should be able to put. All right, so let's unravel multiple things here, which we've got to unravel. We've got to unravel converting to, so you're using subset replace, right?
Yep.
Okay, so then we have to have a utility function. Max, do you have a utility function that turns it into these rules like that? I mean, I know I had one of these ages ago, right?
Well, there's 2 pattern rules.
Okay. And where is that? What context is that in?
Well, you should have it already. It's in set replace context.
Okay. All right. Well, but it would be good not to have to. Okay, so then you're going to call that. Okay, so here, Jonathan, can we put that in? When
Yeah.
you make this, can you just insert that 2 pattern rules there?
Yeah,
so,
of course.
So we can use the regular.
My rationale was only that the design of set replace kept changing, so I wanted to develop this independently of the set replace API. But if that's definitely going to stay, then I can change everything to use 2 pattern rules.
Okay, could you do that right now? It should be very straightforward.
Yeah, of course.
And then, Max, could you remove the message that complains if Wolfram model is fed weird
Yeah,
stuff?
I can do that.
Okay.
You mean you want me to remove it right now?
Yeah, why not? I mean, why not? If you're thinking about it, let's do that, because we're gonna. This is sort of final assembly of a bunch of components here.
Well, I need to make sure it doesn't break anything. So
yeah. Okay. Fair enough.
It's not instantaneous.
Yeah. Fair enough. Fair enough. Fair enough. All right. So look, let's just parameterize what we're doing here. Okay. I think we've got some refactoring of the multi-way system Okay, let's make a list of what we need to do. We got refactoring the multi-way system code. We've got finishing the documentation of Wolfram model. Okay, preparatory to it going into the function repository through a packlet. And I have to say, it could be that the easiest thing to do would be to put essentially all of the code we're dealing with here into a packlet. So that...
Well, that's what I'm doing right now.
No, I understand, but there's an issue for Sushma because we've got all these interdependencies between these different functions. See what I'm saying?
Yeah. I mean, I think the question is if GitHub is fine or we need it in stash.
I don't care. I don't care. You do it. I mean, but it would also be good if these things, when you looked at the source code in the function repository, it wasn't blank.
Sure.
Thing.
Yeah.
Well, what do you mean? What do you want to do then?
I'm not sure.
Well, if we just load the packlet, it's going to be pretty blank.
Well, the trade-off, look, if everything works, I would prefer to just do that. But some of these utility functions, I at least want to keep modifying them.
What do you mean? So how does it work? So if you modify the function repository file, it's not going to be in the packlet.
I know, so that won't work. Unless we have manual steps there, which perhaps we should have for that now. I mean, I'm hoping that once we've, I'm hoping that what's going to happen is we've got a bunch of code development right now that's going to last another couple of days. That then the code development, this code development will slow down. We'll be using this code, but we'll gradually tweak things with the same API. Am I making sense? Right, so we don't have to, so you guys can tweak stuff. I'm not going to be modifying it. Make sense?
For the most part, yeah.
Okay, fine. So let's define what we need.
I'm not sure we would not need new functions later on.
No, we may need new functions, but some of those could be added. Once all this stuff is in the function repository, it's easy to add a new function that has dependence on all of this stuff. See what I'm saying? Right?
Well, I mean, it wouldn't make it easier for me, but I can imagine it's...
Well, it's easy. No, why isn't it easier for you? You just call the function repository functions.
Well, it's easier for me to just put it on in one packlet.
Well, fair enough. That's what you can do if you want to. Okay.
Because the problem is function repository. It has a very large latency.
No, I understand.
I mean,
so you can keep putting it in a packlet. Okay.
Stuff.
Okay. Listen. Let's get a deadline, a couple of days. Let's try and assemble all this stuff and get it in the function repository. Reasonable? Whatever we have, we should get in the function repository. Is that fair? Even if some of the documentation is slightly inaccurate, I wish we had futurization. It's really annoying that we don't have that. I mean, I have an urge to just basically put, okay, Sushma, what are we going to do with respect to futurization here?
I think we could put it in author notes for now. That is our
No, because it's got to be knitted into the documentation here. That's going to be a total mess to do that. Okay, that will not be acceptable. We'll have to have something which goes through and scans for some particular beginning of line character and removes those cells or removes those lines. That's the only option I see.
I think we need to distinguish the source code from the product. The source code might contain featurization, but the product shouldn't.
Obviously. Although what we're going to do for the function repository, the function repository source will contain futurization in the future.
Yep.
Okay, but right now, because those guys don't have futurization, we're going to have to do something hacky to get around it. I don't know how much we'll have to do. Maybe we can put in author notes, but if we can't, we'll have to do something where we actually go through and process these files. We'll see.
Do
We'll
need
see
to
in
do
the
it
next.
anyway.
I'm sorry?
We do need to process these files anyway because they're not in version control. So
Well,
they're
you
not
can
actually
process them.
sources.
I'm not going to touch that. They're not going to be in version control because they're going in the function repository, which has its own version control. I mean, they're in Dropbox, which has version control
I'm
as
not
well.
sure that's, well, it's not really version control.
I mean, I
Look.
think at the list what we should do is we should do one where we are editing things and and then make a copy of it which we'll publish, because once we actually submit it, there is no guarantee that nobody will edit it, because the reviewers
exactly.
will edit it, the QA will edit it. So
I understand. What?
I just
Wait,
added a
what do you
notebook
mean?
which has the pattern rules.
Oh, great. Okay. Okay.
They will
Just
edit
take,
it
before Sushma has
themselves
to go,
instead
which
of-
is in 4 minutes, right?
Yeah.
I want to agree what we're going to achieve here, okay? What we need to do is we need to do an initial assembly of everything so
Yeah.
that we can start using these things from the public function repository, okay?
So,
it won't be perfect,
yeah.
but we need all these functions in there.
So apart from hypergraph, apart from hypergraph plot, multi-way system, and some other things that Max and Jonathan are working, I can get the rest of them cleaned up and submitted to function repository in a couple of days. I think the things that Jonathan and Max are working on are slightly more larger and requires more, detailed documentation.
We've got most of that documentation. We should finish it. We are in a position to finish it, but it's very important that those things go in the function repository, even if they're not publicly, they're publicly visible if you look for them, but not otherwise.
Okay.
Okay. We need to assemble everything. We can then tweak it and improve it, but we need to assemble everything.
Yeah, I was just extending
also, rule
their
plot
deadline.
is not finished yet.
What?
Rule plot is not finished
Well,
yet.
I understand that. I understand. It's okay. We want to put it in there so that we can start writing code that is written in.
No, I mean, it's not finished at all.
Okay, I
The
don't care.
version you
So-
have is not, I mean.
First of all, I think rule plot is tricky because we have a system rule plot.
I know, but this is using up values on Wolfram model for rule plot.
Okay.
So that's okay.
Mm.
And that's something we can do in the function repository.
Mm-hmm.
Okay. I mean, look, this is a typical final assembly problem. Okay. And it won't be perfect, but the most important thing is to do a final assembly.
Yep. Okay.
And then we will make it better and better. Okay. Once it basically works. And because, okay, let me explain another reason. As we start writing these exploration notebooks, we want exploration notebooks that will go on working. See what I'm saying? So we don't want code that isn't, basically most of the exploration notebooks we have right now will stop working, okay? Because they don't use the final version of these functions. Am I making sense?
Yeah.
So we want something where we can write notebooks which will go on working, even though the results might change because the functions might end up being better, whatever in the future. And Sushma, did you hear from Ed or not?
No, I did not. So
you can link the specific package files from the notebooks. In this case, I will guarantee to.
No, we're not going to do that. We're not going to do that. No, let's not do that. Let's use function repository functions, which gradually will get better. These, you don't want to do
how
that.
can I mean? But how we can guarantee that they will not stop working?
We can't. We can't. It's a risk. It'll be okay. These are just working notebooks, right? They don't necessarily have to rerun, but I don't want to find out that the things we build, the larger scale structures we build, like rule filtering functions, that their structure stops working. Okay. I don't know.
Well,
I've done
that's
many of these
exactly
kind of
why I'm
exploration
saying
things
they
before.
should keep it in the same
But,
repository.
What?
That's exactly why I'm saying
But we
should keep
shouldn't,
it all in the
because
same
it won't
repository.
work. It won't work. These are explorations. Most of what we do will be a waste of time. We're not going to screw around with repositories to do that. It's not worth it. We want a stable base of core functions, which we can use, which will gradually get better. That's how we should do this. It's always a very suspicious sign when somebody says, trust me, I've done it this way many times before, but it is the case. This is basically how I did the NKS book stuff, which, yes, 20 years later, it's a nuisance to get it all working perfectly. But we didn't have any, it's okay. It is possible to do it. But much more important was that I got the thing done in the first place. See what I'm saying? So, and much of what was done there, you can see in all of the, I've got all the files. You can see things, it worked in one way. I realized it was wrong. I changed it, et cetera, et cetera, et cetera. Make sense? And, that's what we need to do here. But we need the base of functions in the next few days that comes together so we can actually use them. Make sense? Nobody agrees.
Yep. And you were asking about Ed. He has not replied to me yet, but I will make sure that we get something for tomorrow.
We really need to, because
Yeah.
otherwise he's being useless.
Yeah. Okay.
Okay, you need to go.
Okay.
Okay.
So-
Hey, Sushma. Yeah.
Yep.
Okay. You're going to stop recording, or?
It is going to stop recording. Yes.
Okay, so I can record it instead.
Yeah. I'm gonna.